So the purpose of Arden's theorem is, given a finite automation, let the finite automation be an NFA or a DFA. This NFA can be without epsilon or with epsilon, and it can be a DFA also. So from this finite automation, if you want to construct a regular expression, we will be using the Arden's theorem. Okay, so let us discuss one example under this. So this is the example we have, and this is an NFA. So how can we say that this is an NFA? Is here if we observe the transition of Q1 on input alphabet 0, Q1 on 0 it is transitioning to Q1, as well as Q1 on 0 it is transitioning to Q2. So with this I can say that this is an NFA, because on single alphabet I have two paths. It is going to two different states. So it has two paths. So this is an NFA. So now we should construct a regular expression for this. So to construct so we will be writing the equations for each state. Okay, so let us start with the first step. So that is, let us write the equations for each state. Each state we will be expressing as an equation. So let us write equations for each state. So let us start with the first state. The first state is Q naught, right? So let us take Q naught. Okay, so Q naught, yes. So how we will be writing a particular state is, okay, so you have to write the state multiplied with the input. The state multiplied with the input alphabet we will write. Okay, so Q naught, so here Q naught doesn't have any input alphabet or any incoming paths. It doesn't have anything. Okay, so this state should be the incoming state, not the original state. So Q naught, any state can be expressed as an incoming state multiplied with the input alphabet. So here if you observe Q naught, so Q naught doesn't have any incoming states, or it doesn't have any self loops. So there is no input alphabet for this particular state. This is a start state, just this is a start state, but it doesn't have any incoming arcs or any incoming alphabet. So we will be writing as Q naught will be written as epsilon. So then how can we write Q1? Okay, so let us also state Q1. So if you observe Q1, so Q1 has an incoming arc. Okay, so Q1 has an incoming arc. The incoming arc is with input alphabet 0. On 0 it is transitioning to Q1 itself. Okay, and it has another incoming arc. Q naught on 0 it will transition to Q1, on 1 also it is transitioning to Q1. So that means we will be writing Q1 as Q naught on input alphabet 0 plus Q naught on input alphabet 1 plus Q1 on input alphabet 0. You should know how to write the state equation. Suppose if any state is a start state, only associated with the start state we will be having an epsilon. Associated with the start state we will have an epsilon, and then if we have epsilon plus, so epsilon plus all this thing only for the start state. Epsilon plus incoming state into input alphabet we will be writing for the start state. For remaining states you will not have this epsilon. You will have only incoming state multiplied with the input alphabet. So only here we are writing epsilon, and it doesn't have any incoming state or input alphabet. So Q naught is expressed as only epsilon. If you observe Q1, listen carefully, if you observe Q1, so Q1 has incoming arc from Q naught. One incoming arc I have with input label 0 as well as with input label 1, right? So I am expressing this as incoming state. Incoming state is Q naught, and input alphabet is 0. Again incoming state is Q0, input alphabet is 1. Again, if you observe, here I have one more arc, so that is Q1. So the incoming, so to which state it is going, the incoming state meaning is to which particular state it is transitioning to. It is transitioning again to Q1 on input alphabet 0. So Q1 0 I have written. So now similarly, you people tell me for Q2. So how can I express as Q2? So yes, Q2, Bhumika has given me the correct answer. Q2 has, this is one incoming arc, here I have another incoming arc. So Q2, Q1 on 0, it is transitioning to Q2. Again Q1 on 1, it is transitioning to Q2. Q2 on 1, it is transitioning to Q2. So I can write it as Q1, Q1 0 and Q1 1 plus Q2 1. Yes, Shreya also has given me the correct answer. So this is how we will be expressing them in terms of equations. Given a finite automation, each state will be expressed as an, each state can be expressed as an equation. So this is how we will be writing. So now these equations we must solve. So these equations should be solved in order to get the resultant regular expression. Okay, so now let us name these equations. Okay, so let me name it as 1, 2 and 3. So if you observe equation 1, so okay, from equation 1, what is the value of Q0? I got one value, so Q0 value is epsilon. Okay, so this result I already have. So now let us substitute this value in equation 1, so that is for Q1. Okay, so wherever I find Q0, I will be substituting it with epsilon. Epsilon into 0 plus epsilon into 1 plus Q1 0. Okay, what I did, just I have substituted for the value of Q0. So in place of Q0, I just substituted epsilon. So now let us simplify this one. Okay, so if I simplify this one, what will I get? Let us take epsilon as common, then I will have 0 plus 1 plus Q1 0 as it is I am writing. So now, so you should remember the equivalence, the identity rule, epsilon into P plus Q. So what it will become? Epsilon into something. All the time you should remember the equivalence rules. Epsilon plus anything can be written as, let us treat this as epsilon plus r star. Okay, so let us treat this as, so it is in multiplication ma. So okay, so the equivalence rules here is epsilon into r is r itself. So this is the first identity rule that we discussed. Epsilon into r is r. So I can write it as 0 plus 1 0 plus 1 plus Q1 0. So now you can observe the format. Okay, so as per Arden's theorem, what should be the statement? As per Arden's theorem, what is the statement? R is equals to, suppose whenever a regular equation is in the form R is equals to Q plus RP, so then the solution I can write it as QP star, right? So now let us take this as Q. Okay, Q1 is R and P is 0. Is it clear? So this we are comparing with the Arden's theorem. As per Arden's theorem, the regular equation format is R is equals to Q plus RP. So R is repeating here and here. So similarly Q1 is repeating in two places, Q1, Q1. So I am taking Q1 as R. Okay, so this 0 plus 1 entire term as Q and 0 as P. So now what is the solution for this? What is the solution for this? qp star, yes. So q is 0 plus 1 and p is 0, so qp star is the solution. So I can write as q1 is equals to 0 plus 1 and 0 star. qp star should be my answer. So 0 plus 1 is q and p star, p is 0, so 0 star. So now I got the solution for q1 also. So q0 value is epsilon, and then q1 value that we have got is 0 plus 1 into 0 star. So now let us solve for the value of q2. So let us solve for q2 value. So the equation for q2 is, so let me write once. So can you give me the equation for q2? Equation for q2 is q1 0 plus q1 1 plus q2 1, yes, q2 1. So this is the equation for q2. So now we already know the value of q1. So let us substitute for the value of q1. So if I substitute, q1 value is 0 plus 1 into 0 star is the value. Okay. So this the 0 should be written as it is, plus, let us once again write 0 plus 1, 0 star 1 plus q2 1. Okay. So actually this is the substitution for q2, but if you observe the automation, q1 is the final state, and with this itself the string acceptance will be finished. So you need not proceed further. So if you proceed further also, there is no use. So this I can treat as a dead state. I have a path, but never we will be using it. If I use it also, it will be an incomplete string. So I need not solve for this q2. Have you got this point? Here q1 is my final state. So whenever we are working with string acceptance, we will be checking up to the final state only. So we will start with the start state, we will end up with the final state. So if I solve for this final state, if I could find the regular expression value for this final state, that is my final regular expression. So here from q1 I have one more state q2, but this q2 is never going to reach the final state. So though there is a path, it will never reach to the final state. So I can treat this as a dead state. One extra state is given, but there is no use of it. So okay, so I need not solve for the value of this q2. So that means I have already got the regular expression. So for the given automation, the regular expression is q1 itself, whichever is the final state. Here q1 is the final state. So whatever is the value you obtained for q1, so this is the value for q1 that we got. So this will become our regular expression. Okay. So since q2 is not reachable, or we can also call it as a dead state, okay, we need not solve for q2. We need not solve for q2. So therefore the regular expression is the value of final state. So this you should always remember, the whatever is the value of the final state, so that is the resultant regular expression. So therefore our regular expression is the value that is obtained at final state q1, which is 0 plus 1, 0 whole star. So this is our final regular expression. Is it clear? Will you solve one problem now? Is this clear or any doubts, ma? Anybody? I have more number of people, but I am getting only few responses. Only 158 students. When I joined the class, it is 180 plus 20 students have gone already. Okay. Fine. So if anybody has a doubt, you can ask me, ma. So okay, let us proceed with one more example. So this you should only do. Okay, I'm not going to help you for this. Okay. So let me give the problem. Solve. So find the regular expression for the following NFA. For the following NFA. So let us take the NFA. All of you take it parallelly, ma. So we have a state name 1, and this is our final state. I also have a state 2. So let us take the input alphabet also. So this is A, this is B, this is A, and again this is A, and this is also A. So this is the automation that is given. Yes, so now can you tell how can I call this as an NFA? Why we are calling this as an NFA? Why not a DFA? Three on A, it is going to 1, 5 as well as to 4. So to three different states it is transitioning. Okay, so it is transitioning to 1, it is transitioning to 5, it is transitioning to 4. So 3 paths it has. So it is an NFA, not a DFA. Very good. So now, yeah, so if you tell me the solution, I will do it. This I am not going to work. Make it bit faster. So first, the first thing that I have to do is what is the first thing that I should do? No response. So let us write the equations first. So the equations of NFA states. Start state E. It is not E, it is 1. 1 is the start state as well as it is the final state. It is not, okay, epsilon. Okay, for the start state you are saying epsilon, right? So, but here the start state is 1. Okay, so if you start with 1, so always let us remember the formula. So what is the formula? Transitioning state, or let me write it as state into input. So any particular state can be written as state into input if it is start state. Okay, so along with this we will also add epsilon only if the state is start state. Okay, so here 1 is the start state. So what should be the equation? 1 is the start state. For 1, what should be the equation? 1 is 3a plus 5a. So the incoming arcs to 1 is, from 5 it has an incoming arc, from 3 it has an incoming arc. So we can write it as 3a plus 5a, and 1 is the start state. Since 1 is the start state, we will also should add epsilon. Yes, very good. Shreya is giving me the correct answer. 3a plus 5a plus epsilon. Similarly, let us write for state 2. Cheppandi meere cheppali equations. 2 is 1a. So for 2 I have only a single path. Okay. So we will write it as 1a. Only one incoming arc it has. Similarly 3. 3 is 2b. Yes, correct. 4. What about 4? 4 is 3a. Whatever you are saying, same thing I am writing. You are saying correct only. Next 5. So 5 has got 2 incoming arcs. 3a plus 4a. So 5 can be written as 3a plus 4a. That's it, no? 1, 2, 3, 4, 5. So we have written the equations for all the 5 states. So now my regular expression is nothing but, to get my regular expression, if I solve the value of state 1, because it is the final state, whatever is the value of this final state, so that is my result of regular expression. So that means I should solve for this particular equation. I have to solve for this equation in which I have 2 more states, 3 and 5. So if I get the values for this, my solution is done. Okay. So now let us find out the value for each state. From where shall we start? So here I need the value for 3a first. For state 3 I need the value. Yes, yes. So for state 3 value is 2b, but again I have another state 2. So this is one state, right? So again I need to solve for this. For 2, if I substitute for 2, 1a, 1a, b. So again for 1 I have a greater value. Okay, so let us use this. Value of 4 is also 3a. So value of 4 is also 3a. So can I substitute in this? Let me see. 2ba. So just value of 3 I am substituting using this. First let us number these equations. 1, 2, 3, 4 and 5. Okay. So 3 is 2b. Okay, so just I have taken it as it is. So if you take equation 4, it can be written as 3a. So in place of 3 I have the value 2b. So I have just substituted 2b and a. So then again if you see 2, it is 1a, 1a, b, a. So again we are with 1. Okay, so 4 is written as like this. 5 can be written as 4a. So again I need to solve for 4 now. So let us substitute in that equation. It is 3a plus 4a, right? So 3a if I substitute, so any one form I should take. So for 4 I have a value 3a. So let me take it as 3aa. Okay. So now let us take 3a as common. Okay, let us take out 3a, so then it is epsilon plus a, which can be written as a again. Epsilon plus a is a only. So and I also have the value for 3, somewhere I solved the value of 3. Okay, so let us keep this value 1ab. So the value of 3 is 1a, b and one more a. So from this epsilon plus a, this can be written as a. So the value that I got is 1a, b, a, a. So now I have the value for 5. Similarly, I have the value for 3. So now let us solve for equation 1. Let us substitute these values in equation 1. For 3, I have this value. The value of 3 is 1ab. This is one value I got, and another value I got is for 5. So this is the other value. So now let us substitute these values in equation 1. So equation 1 is 1 is equals to 3a plus 5a plus epsilon. Yeah, 3a value is 1ab and 5a value we got is 1abaa plus epsilon. So now we should try to get into the format of Arden's theorem. So that is, I should be able to write it as q plus r into p. So that means I need to somehow simplify these terms. Okay, so let us try to take a common value from these equations. Are you getting? As per the Arden's theorem, I should have my regular expression in the form of r is equals to q plus rp. So this is the form I should get. So here my r value is 1. So here I am getting r as 1, but I should get a value for q and p. So if I take epsilon as my q, but then for p there is no common value. So we are trying to get for a common value. So now let us 1. Yeah, let us take out 1ab. 1ab if I take as common, so then I will be getting epsilon plus aa. So this is the outer epsilon that I am having. So then I have 1ab. Epsilon plus aa can be written as aa itself. What happened ma? 3a is 1aba na? I missed out one more a. Is it so? aba. Okay, so I missed out one more a then. Okay, so here I can take a as common. So then here I'll have only one epsilon, isn't it? Epsilon plus a. So and finally I got 1 aa plus epsilon. Is it correct, ma? Yes. So now I can make it in the form of Arden's theorem. So as per that I can take r value as 1, q value as epsilon and p value as aba. We have solved for everything, right? We didn't miss any. Yes. So now what is the final regular expression that we got? So this can be expressed as qp star. So that means 1 can be written as q value is epsilon, abaa star. So which can be written as epsilon into r star is r star itself. So it can be written as abaa whole star. So this is our regular expression. Is it clear, ma? Shall I proceed for the next? Yeah, fine. So now let us see one more procedure. So with this we finished with the Arden's theorem. What is the purpose of Arden's theorem now? What is the purpose of Arden's theorem? Answer please. Very few are active. Purpose of Arden's theorem. With the help of Arden's theorem, what have we done now? Convert a finite automation to regular expression. Very good. So now let us see the other way. So given a regular expression, so given a regular, actually for these steps are there, so that I will just post in the PPT, ma. You can go through. So the same procedure whatever we have done, so that you have to give in terms of statements also, so that I will just post in the PPT. So now let us see how to convert a regular expression to a finite automation. So yesterday we have seen this one, right? I'll just show you once. Yes. Constructing a finite automation for a given regular expression. Okay. So you can also construct a finite automation given a regular expression. So in that what we can do first, the regular expression can be converted to NFA with epsilon moves, right? So this is the first thing that we can do. So this can be also called as equivalence of NFA and regular expression, or conversion of regular expression to an NFA. So let us see this one. I'll just little extra time. Is it okay with everyone? I want to finish this topic also, because we are just in the beginning of second unit. So with your permission I'll proceed. Everyone, please respond. Priyanka is saying okay. What about the other people? No ma'am, tomorrow. No. Okay. Why ma? When will we finish our portion? All knows only. They are exhausted. Okay, fine then. So without your interest I can't proceed also. I don't want to trouble you people. Okay, at least practice up to here. Based on this Arden's theorem, I will post 2 more questions. Okay, whenever you have time, you just practice it. So then you will be clear. And for the next class, you just revise the conversion of NFA with epsilon to NFA without epsilon, and from that to DFA.